so I'm working on the midterm study guide for college algebra, and I'm going to show you number 11 from your study guide. It's kind of a trickster. We don't do this just a whole lot, but it's the cube pattern. If you were to factor the sum or the difference, it works for plus or minuses in cubes. When you factor, the pattern is you take the cube root. So it have to be perfect cubes for this to work. But if you have two perfect cubes, you cube root them. So just basically here you bring down the x and the y and use the same middle sign. And then the other parenthesis has a little pattern. It's this term squared, these two things times together, so x, y, but you always put the opposite sign for this to work out, and then the last term squared. So it's squared times together with the opposite sign squared. If we were to multiply this back out, this times these three, this times these three, it just works. This multiplies to be that. So it is a true factoring, divided out thing that is a true statement, a form of that. All right, so when you're doing number 11, and it says to solve this equation, it is a cubic equation, a third degree equation, so we're expecting three solutions. To find all three solutions, you have to do it with this factoring pattern, getting it broken apart. So perfect cubes here. 64's cube root is 4, and x cube's cube root is x. And this one's a plus, just like our example. We square, times together with the opposite sign, and square equals 0. This part never unfoils, never factors any further. That is as far as you can go with factoring, but at least now we have a linear factor and a quadratic factor. And they're multiplied together, so we can use the zero factor property, set this equal to 0 and this factor equal to 0, and we'll be able to solve. Because we know how to solve linears, just throw that across the line and that thing's solved. That's one answer. And we also know how to solve quadratics. Quadratic equations that won't factor can always be put in the quadratic formula. Notice A is 1, B is -4, C is 16. So when you use a quadratic equation on that, you do need to ensure that you know your quadratic equation. Okay, the quadratic formula says take the opposite of your B term, which will change it back into +4, plus and minus for our two answers, B squared. Even if it's a negative number, you're squaring the negative as well when you plug it in for this variable, making it +16 minus 4 times the A times the C value, all over 2 times the A value. Next thing we do is simplify the stuff under the radical. There's a 16 and a minus all of this. So 4 times 1 times 16 is 64. We've got 16 minus 64 over 2. Keep reducing. 16 minus 64 is -48. So we're going to have an imaginary number anytime we get a negative under the radical. But we do need to reduce that as far as we can. Everybody wants to cancel these out right now, but hang on to that because you've got to take both of these divided by 2. This will divide by 2, but so will this. So next thing I always recommend is reducing the radical. There is an I because of the negative. So you're going to have an automatic imaginary. And then 48, square root of 48, we can reduce down. You can do that a couple ways. One way is with a factor tree. That's one way we've talked about. Or the quickest way is to think of 48 as being 16 times 3. The square root of 16 would be perfect, bringing out a 4, and then you'd leave the 3 in. So now we have 4 plus minus. We have a 4 out of the radical and an I, and then a 3 left in the radical, all over 2. Now, both of these divide by the 2, so now we're ready to do it. 4 divided by 2 will make that 2. And then also take this 4i divided by 2, we can do that, and it makes that a 2. So both of these you divide by this 2 down here. And then that is your final form of that. So notice this is 2 answers. We have 2 plus 2i radical 3 and 2 minus 2i radical 3. 2 answers plus this first answer, -4, for a total of 3 solutions for this third degree. You should have 3 answers. So you type all that in as your solution. All right, that's the answer for 11. All right, let's go on down to number 12. Number 12, we have a picture, a rectangular picture. Then we put a mat around that picture, more uniform than this freehand drawing I've got. But what we know is the mat is X inches wide. We don't know how wide, but it's uniformly around this picture. And then the whole thing, the picture plus the mat, makes it 43 inches by 34 inches. And so we've got a multiple choice question that says, express which of the following equations says that the area of the picture is 900 square inches. So remember, the picture is this part, 900 square inches. So this little rectangle that's inside, it's length times its width. We know area is length times width, should equal 900 in this case. So we know this thing is 43, but this is a little shorter than that. How much shorter, you might say? It's X shorter. They've come in X inches. The mat around it, we don't know how wide it is. It's X. So on each side, there's an X. So we would say the length of this picture is 43 inches minus X, or minus 2 X's. The width, for the same argument, this is a little shorter in here, but it's 34 outer dimension. Come in X this way and X that way. It's 34 inches minus 2 X's. So that would be a way we could algebraically represent that length, and that width multiplies to be 900. So that's the equation you should be looking for on number 12. Now on number 13, you actually have to work it out. This one you just find the equation. 13, you've got to do it. So on 13, we've got a rug in a room thing. So it's a similar question. It's a border question. You've got a rug that you're going to lay down in a room, but you're going to leave a border around your rug. So you see, here's your rug, but we're centering it inside your room and leaving a uniform, kind of like the mat thing with the picture, a uniform flooring. Maybe they're hardwood flooring, and you're showing the same amount uniform around it. So it says the room is 12 by 15. So the actual whole room out here, 12 feet by 15 feet. And again, we're going to call this amount around it X. It's unknown in the problem when you read it. So it says that the rug itself is 108 square feet. So this rug right here is 108 square feet. So how can we make an equation to figure out the dimensions of the rug? That's the question is, or how wide is the border actually? Either way, you could figure it out from this. So to write an equation, this rug's length and width, we could represent just like we just did. The length, it would have been 15 all the way across the room, but coming in X makes this length right here 15, subtract X, or subtract 2X. That's the length of the rug. The width of the rug, for the same argument, it's a 12-foot room coming in X this way and this way, because it's the same all around, is 12 minus 2X. So length times width, whenever we cut it into just this rug, equals 108 square feet. Again, area of a rectangle is length times width. So that's the equation we have to solve. To solve this, we're going to have to re-multiply it and get it in standard form. So we're going to take 15 times 12. 15 times 12, you all with your calculators would do that quickly and get 180. The outer is minus 30x. The inner is minus 24x. And the last times last is 4x squared equals this 108. All right, so we can see it is a quadratic equation. So let's get that in standard form. That's on my left side. I can combine my x's and get 54x. And I need to bring the 108 across, so it's all over on one side. So 180 minus 108 is 72. So now we've got this quadratic in standard form, and if you hate factoring, you jump into the formula, the quadratic formula, an A, B, C value, and crunch that out. I'm going to work at it from a factoring standpoint. I do notice all these numbers are even. I could make it easier on myself. I don't think I can divide by 4, but I think everything divides by 2, and I can make the problem a little easier. halving everything. So that's always an option if you want to do stuff like that to make your equation equivalent but easier. And that's going to help a little bit when I go to factor it, or if I decide to use the formula. Either way, smaller numbers are helpful. So I can see the only way to get 2x squared is 2x times 1x. Next thing I see is I need a negative times a negative to get a positive on the end. Now there's lots of options to get 36. Maybe 9 times 4, 12 times 3, 2 times 18. So I really don't know. I just have to try some things. I'm going to do 4 and 9 and see if that works. I can kind of already see it doesn't. That gives me 4x and 18x, which is 22. So let's try, let's see, what else did I say? 3 times 12, I think that's the one. 3 times 12, negative negative makes a positive 36. The inner inner and the outer outer combine to be what I needed, negative 27. So that combination foils to be that. So I found what works. And then I set each factor equal to 0. Just hang on just a second. And then when I solve each one, I'm going to get a 3/2 and a 12 solution. And I look back at my original problem, which I erased now. I had this room with a rug in the middle of it. And the room was only like a 15, was it 15 by 12? I think it was 15 by 12. And you're looking for how wide to make the border. Well, we can't have a 12-foot border. You wouldn't have a rug at all in the room. It would eat up the whole room. So this number is actually too big when you look back at the original problem. That's what's wrong with it. The answer 3/2 is the only one that's reasonable back in the original. So 3/2 is your final solution, how wide to make the uniform part.